Hello and welcome to Fusion 360 tutorial. My name is Lawrence, and today in this tutorial we'll be diving into creating an intricate glass bottle using advanced techniques. We'll be exploring the lock command, the offset construction plane, the intersecting geometries, and the guide rails. By locking four sketch profiles together, we will recreate a stunning glass bottle, as you can see. So fasten your seatbelt and let's get right onto it. So we create a new component. We'll rename the component to glass bottle before clicking OK. So we know that component would help us keep our design organized, especially when we get to multi-part models. To create the first sketch profile, we start our sketch on the XY origin plane. So we use the center rectangle. Using the center rectangle will help us keep the triangles, the bottle, symmetrical to the center origin plane. We assign horizontal and vertical lengths 76 and 63 millimeters respectively. We can right click to drop the triangle. So next we'll be using the sketch fillet command to add rounded portion to the lower parts of the bottle, the triangle here. Okay, so that's okay. So sketch fillet command can be seen under the modify menu. Once selected, highlight the sides of the rectangle. Notice that fillet command would round all the edges across the rectangle. We choose fillet radius to be 7. It's good to know that sketch fillets are not ideal. As you can see, a warning letting us know they've removed some of the constraints. When possible, we try to avoid sketch fillets in favor of modeling fillets. However, loft and swift are two common cases where sketch fillets are unavoidable. We can now select finish sketch as our sketch profile is complete. Fusion 360 does not allow you to create regular shapes floating in space. All sketches must be started on a planar, flat surface, origin plane or construction plane. We can see the different planes. Offset construction planes are usually used because they always require an existing sketch or a planar surface to offset from. We'll activate offset construction plane and select the bottom origin plane of the previous sketch. We'll specify the specific distinct distance by typing 114 and pressing OK button. We can now create a new sketch on the new offset to sketch out the next profile. We select create sketch and click on the new offset plane. This time also we'll select center rectangle to continue with the next. This time we will make the rectangle larger by assigning 96 millimeters and 76 millimeters respectively to the lengths. Okay, so next we go to the sketch fillet. This time around we'll be using a larger sketch fillet because we are working with a bigger triangle this time, a bigger rectangle rather this time. We also select the sides as we did in the first sketch. So we'll make sure we select accordingly to avoid error pop-ups. We'll use a fillet radius of 20 millimeters. Activate offset plane from the solid modeling tab and select the previous sketch. This time we offset 38 millimeters from the second plane. We will also have to pay attention to the plane we are offsetting from, whether the first, second, or so that we would not make mistake in the distance we expect to get. We create our fourth and final plane would be 88 millimeters far from the previous plane. Next we create circle on the third plane. Highlight, select create sketch, select the circle. Start the circle at the center origin plane and define as 20 millimeters. Let's take a minute to view our construction from the home view to see if the construction is correct. Everything is okay. We select Finish Sketch. So next, we create sketch on the last plane. Then we activate the center circle command. This time the circle will be 30 millimeters diameter because we want it to be smaller than the previous. Finish sketch, then view from the home position. So we now have our 4 planes from the top to the bottom. As you can see, we click the highlight blue showing they are a fully closed shape. Okay, next we activate the loft command and the solid modeling tab. Okay, so that's the loft command. Once selected, Fusion expects us to select the profiles in the order to which we want them to be connected. In our case, we start from the bottom plane. Notice what happens. As we join, you observe that the planes are connecting to itself. Sketches connecting together, resulting in a 3-dimensional shape. Okay, viewing the bottle from different shapes, we realize we've not attained our perfect desired shape. So we can further modify this with different tools. The first option is changing the connection to direction. So let's do that. This automatically applies an angle based on the sketch shape. So this is close to the shape we are looking for, the ideal shape. However, we can add guide rails or center lines to further define the shape. So rails are 2D or 3D sketches that influence the loft shape between 2 sections. So they must touch every profile in the lock. In our case, the rail will have to touch all 4 sketch profiles. Also, we can use the center line at the middle of the shape, but only one center line can be used at every given time. Let's press cancel on the dialog so we can sketch the guide rails. Okay, to create the guide rails, we'll be using the spline tool and the regular line tool. Also, to know that you can create guide rails with sketch entities as long as they touch each sketch profile. We'll be sketching the guide rails on the XZ origin plane as it lies immediately at the middle of the bottom. Exactly. One thing we want to ensure with the guide rails is that it snaps into each of the various profiles. If not, we'll get a common error which states that the guide rails is not touching the profiles. Okay, to ensure that the guide rails will be touching each of the profiles, we can use the intersect to reference each of the profiles. So here we'll be selecting the sketch lines to intercept, as you can see in the intercept pop-up. As we hover over the sketch lines on the left side, notice the red dot that appears at the middle. Those dots represent the area of our existing geometry that intersects the active sketch points. By selecting those, we're letting the software know that we want to reference this existing geometry. In the current sketch, we'll select each of the 4 profiles. So you'll observe that the sketch automatically selects the both sides. But we'll eliminate the left side of the rectangle as we'll be mirroring in a very short time. In the intercept option, make sure the projection link option is checked. This will ensure that our intersected geometry will update automatically if we want to update the dimension of any of our existing sketch geometry. Select OK Notice the purple lines on the intersected points. We can now look at the sketch from the front view. Let's start by drawing a regular line that connects the top two circles. Notice that the line intercepts on those points we already selected. Okay, so we then activate the Fit Point Spine command. Start from the bottom point and select the next 2 points. Then you can press the Enter key or mark the green point to uncheck. We'll select the spine handle and adjust it until it fits to the already existing line. This will ensure our guide rails is continuous and treated as one line. Next, we can select our spine's point, the handle, and adjust it to our desired shape. We can always edit, so that's one of the advantages of using this technique. So we are now done with the left. Let's now mirror it to the right. So activate the mirror command. Make sure you are on the sketch tab. Okay, once active, we'll select our spine and our regular line. Okay, yeah, selected. Remember, we started our sketch on the center origin. This means we can reference our vertical axis as the mirror line instead of creating additional sketch geometry. Once complete, select OK. Notice the mirror geometry that just appears on the right side. We can activate the loft command from the solid modeling tab. So we select the 4 sketch profiles in order as we previously discussed. We can now select the arrow in our guide rail, which will help us further define our shape. Notice how the shape of the bottle changes as I select each guide rail. Guide rails can help you define lofts, creating more defined and complex shapes. If you aren't getting this correctly, double check whether your spine and line are connected correctly to each of the 4 sketch profiles. Also check if the spine is snapped to the straight line, making it a continuous line. At this point, we'll finish up the bottle by adding up a few more details before making the bottle hollow. Notice that the bottom of the bottle is completely flat, so we'll use the fillet command. So we'll be using a fillet with 5 mm, which would add a very good rounded design to the bottom of the bottle. Good to go? Yes, that's okay. We can select OK. Let's now create a stem on top where we can add a thread. We'll sketch on the top surface of the bottle. Activate the center circle command. Study the center origin and define the diameter as 27. We can now select the extrude command, select the circle as the profile to extrude, and define the distance as 12 mm. Before selecting OK, make sure the operation is set to joint. By selecting join, this 3D body will join to the existing 3D body, resulting in a single body. This is crucial for the shell command to work in the entire shape. So we now activate the shell command. Select the top portion of the bottle as we remove the bottle opening and select the thickness as 2 mm. If at this point you get an error message, you need to go back and edit your guide rail setting. Lastly, I'm going to add one more fillet to the top. I'll make this fillet radius 2 mm. Okay, before doing that, let's observe the bottle a bit. Okay. Alright, so click OK. So next, we add a thread to the top of the bottle using Fusion 360 thread command. Activate the thread command from the Create menu. Select the top bottle surface as the face. Next, check the model option to make a physical thread on the bottle. When unchecked, the trace would only be represented by an image, but will not be included in the model if you 3D print or export the file. The next is the length. We can uncheck to give our desired length to snap to. Lastly, you can see we can define the thread to the different thread standards we have. So for the length, we'll go for 7 millimeters. Afterwards, the bottle is done. Click OK. So we've come to the end. Thank you so much for following through. See you next time.